Hello everyone, my name is Manav Patel. My ID number is 24CS067. Today I am presenting my XR based animation project on the topic 5-stage RISC pipeline. Here RISC stands for Reduced Instruction Set Computer. In this project I have developed a 3D simulation using Angular, Three.js and GSAP animation to visualize CPU pipeline execution. Before explaining the pipeline, it is important to understand why pipelining is needed. In a non-pipeline system, instruction execute one after another, which leads to inefficient CPU utilization. Pipelining allows multiple instructions to execute simultaneously, thus improving throughput. Now I will explain the 5 stages of the pipeline. Here you can clearly see the first one is IF, second one is ID, third is EX, fourth one is MEM, and fourth one is WB. Here IF stands for instruction fetch, ID is instruction decode, EX is execute, MEM is memory extend, and WB is write back. Now I will explain all the stages in detail, what are the role and functions of each stage. The first stage is instruction fetch. It fetches the next instruction from memory using the program counter. The instruction is loaded from the instruction cache. This instruction travels to the next one, which is the instruction decode. It decodes the instructions and read source register from the register file. Control signals are generated. Third one is execute. The ELU performs the computation, arithmetic logic or address calculation for memory operations. The fourth one is memory access. Access is data memory for load store instruction. Other instructions pass through this stage. The last one is write back. Writes the result back into the destination register in the register file, completes the instruction. Now I will demonstrate the how instruction moves through the pipeline. Now I am starting the animation. I will set this speed to 0.5 so you can clearly see. Here are the instruction add, subtract, load, write, and the last one is SW, that is SW. Here are the clock cycle table. It will display how total number of clock cycle needed to execute the program. Here also you can see how many total cycles needed. Okay, so all the instructions are executed, and here we can see that total 14 cycles are needed to execute this program. As we can see, instruction 1 enters the fetch stage. In the next cycle, it moves to decode, while instruction 2 enters fetch. This overlapping continues, allowing multiple instructions to execute simultaneously. Now I will explain all the instruction used. First use is add, which stands for addition. It adds values of register and stores result. The next one is SUB sub, that is for subtraction. It will subtract the values. The third one is LW, it is load word, which reads data from memory. And the last one is ZW, store word, which writes data to memory. Now observe the clock cycle counter. Each movement of instruction represents one clock cycle. So basically there are total 14 clock cycle needed. Now I will show the pipeline table. Here you can see that it is written that all the instruction which is executed, and once it is done, here we can see that add operation is done in 6th clock cycle, subtraction operation is done in 8th clock cycle, and for LW and SW also. So basically to complete all this execution, it total needed 14 cycles to complete. Now I will slow down or pause the animation, which is already paused. In this pipeline, the total number of cycles is 14. This is calculated as number of instruction plus number of stages minus 1. It is the general formula you can use for all the instruction. So here basically there are 10 instructions plus 4, that is equal to 14 cycles. The first instruction takes 5 cycles, and after that each instruction completes in 1 cycle. There is also one here mode, which is hazard mode. Now I will turn hazard mode, and again I will play the animation. Let's see what happens in the hazard mode. I will first reset it on the hazard mode. Play. Here there are only one changes in hazard mode. As you can clearly see in clock cycle 5, there is here it is written stall. Later I will explain why it comes written stall and what are the output of this. Look here, you can see that it exists the 14 clock cycle and it completes in 17 clock cycle. Now actually explain why it is done. So I will first okay, it is paused only. Now we can observe a delay in execution. This happens due to data dependency between instruction. The pipeline introduces a stall which increases the total number of cycles beyond 14. Uh, so here you can see the stall and therefore it needed 17 cycle. In conclusion, this project demonstrates how pipelining improves performance through parallel execution and how hazards affect efficiency. Thank you.